Nowadays, digital voltmeters are so cheap. You can buy them just for a few bucks. They are using a microcontroller to measure the voltage and display it on the 7 segment. But if they stop working for any reason, you can't fix them. You have to buy a new one. Because they are not open source and the manufacturer never give you the programming code. So I decided to make my own circuit without using any microcontroller. First, we have an op-amp as a voltage comparator. The voltage being measured connected to the non-inverting input using a resistive voltage divider. Then we have a sawtooth waveform that connected to the inverting input of the op-amp, and the output of the op-amp connected to a counter. When you switched on the circuit, the counter starts to count up. Let's say the input voltage being measured is 20 volts, and this voltage after divider is 0.2 volts. The ramp waveform started from 0 volt and increasing gradually, and the counter keep counting. Once the voltage of the inverting input get higher than the voltage of non-inverting input, the comparator stop the counter, then reset the counter and repeat this process over again. The clock frequency is 3.9 kHz. You can try different frequency. Then calibrate the circuit by using this potentiometer. This clock pulse goes to the pin 9 of the counter. This is the sawtooth or ramp generator. The capacitor getting charged through this resistor, so its voltage increasing gradually. This transistor periodically shorted to the ground to discharge it. At the same time reset the counter. The latch pin, pin number 6, is so important because you don't want to see the counting process itself but the final result. After designing the PCB, I ordered it from a company called Next PCB. Upload the Gerber file here, you can find it below in the description. Insert the size of the PCB, quantity and color, then add to cart. I received them after a few weeks. I ordered 5 PCB but I got 6. This is the PCB after soldering the components. It has 3 wires just like the commercial voltmeter. The black one goes to the ground of the power supply. The red one is the positive side of the battery or power supply that running the circuit itself. It could be anything between 11 volt and 30 volt. And the last wire is the voltage being measured with respect to the ground. Anything from 0 volt up to 99 volt. If you want to measure the voltage and at the same time using that voltage to run in the circuit, you have to short out these 2 wires together. For the first time using this circuit, you have to calibrate it by using this potentiometer. You can compare the voltage reading of my circuit and the commercial voltmeter. I think my voltmeter is more accurate. This is the sawtooth that I was talking about before. I noticed that the commercial voltmeter is flickering. That's because they're using something called multiplexing. They connect all the 7 segments together in parallel, then activate only one at a time. They do that to reduce the number of pins on the microcontroller. But there is no flickering on my circuit because all 7 segments working together. By the way, only camera can see this flickering, so it's not a big deal. I took these big 7 segments from an old digital clock. By adding a bridge rectifier and more resistors to the voltage divider, I can even measure the mains voltage, but you need a 12 volt switching power supply. And also you have to disconnect the resistor that run in the decimal point. To measure the current instead of voltage, you need a shunt resistor instead of voltage divider. I'm using a 0.1 ohm resistor, and for calibration, a potentiometer in parallel. So as you can see, it matched the clamp meter. I think this circuit is just an educational project, because it's bigger and costs more. The good thing about my circuit that it has 11 mega ohm input impedance, just like the regular multimeter. But this one is only 100K. Please like this video and subscribe to my channel. Thanks for watching.